All right, now we'll be talking about R3, adding and subtracting fractions. Adding and subtracting fractions, let's see, start here. To add two or more fractions with the same, okay, I'm always paranoid about recording, I'm sorry. All right, so to add two or more fractions with the same denominator, we can think of the common denominator as the, quote, name of each fraction. The sum has this common name, just as 3 oranges plus 2 oranges gives a total of 5 oranges. 3 eighths plus 2 eighths give a total of 5 eighths. This denominator is called the common denominator, and the figure 1 illustrates how the sum of two fractions, 3 eighths and 2 eighths, might be diagrammed. Okay, and then digest that. We have 3 shaded and 5 unshaded, and then 2 shaded and 6 unshaded. Well, 3 and 2 is 5, so 5 shaded areas. Okay. This. Alright, so to add fractions of the same denominator, it doesn't get any easier than this. We just basically add the numerators. Okay. So you say 1 plus 2, well, that's 3. So you get 3/5. And honestly, I probably didn't even have to snip that problem because it's so abundantly clear down here. Right. So the second example, I'm pretty sure is the same thing. So we're not going to snip it either. We're just going to go over it. So they all have the same denominator. So all I need to do is add the numerators. 1, 2, 3. So 1 plus 2 is 3. 3 plus 3 is 6. And of course we see our solution down there as 6 over 11. Alright, so this reads to add fractions with different denominators, we find the least common denominator, the LCD of the fractions, change each fraction to an equivalent fraction with a common denominator, and then add. For example, if the denominators are 3 and 5, the least common denominator is 15. Thus we proceeded as follows to find the sum 1 plus 3 over 2 plus 5. Okay, and of course we see that since 15 is indeed the least common denominator, we proceed from there. Okay, but we're going to do it a different way. Okay, we're going to do it just a tad different. Obviously, the textbook has their particular way of doing it, and there's nothing wrong with their way of doing it. But I'm going to do it. I'm going to teach you the way that I do it. Okay, I don't know if it's faster. It's just different. Okay, so we have 3 eighths plus 13 over 12. Okay, so the way I do this, and let's go ahead and let's see. How can I? Okay, maybe I don't need to. I was going to color coordinate 13 over 12. Okay, so the way I do this, the way I do this, okay, first thing I do is I say, what is 3 times 12? Okay, well, 3 times 12 is going to be, let's put a little arrow over here. So 3 times 12 is 36. Put the arrow there. 36. Okay, and then what is 18 times? I'm sorry, not 18. What is 8 times 13? Okay, so again, this 8 times 13. Well, that is going to be 104. So plus 104. Okay, so all I did was I said 3 times 12 and 13 times 8, and then I put that. I added those there in my numerator. My denominator is just simply going to be 8 times 12. Okay, what's 8 times 12? 8 times 10 is 80. And then times 2 is 16, so it's be 96. Okay, I'm not sure if this is going to be an easier way, but we're here now, so let's get it. Okay, so what is 36 plus 104? So that's going to be 140. That's awful. My poor pen. I changed the batteries out, but I don't know. Here's my computer. 140 over 96. All right, so I don't know if this helps anybody, but 140 over 96 is what we get when we add this fraction together. Okay, Well, we can obviously reduce this, right? So what can we reduce this to? Okay, well 140 and 96, well they're both divisible by 2, right? So I can say that that it would be, let's put it in yellow now. It could be 70 over 48. Okay, well that's also divisible by 2, so I can say 35 over 24. Okay, and I believe that's about as yeah, we can't go any lower than that. Okay, so that's the way I do it. Again, just kind of recap, and let's go ahead and let's erase this arrow right here. Okay, what I did was I did 3 times 12 to get 36. Okay, and then I did 8 times 13 to get 104, and then I did 8 times 12 to get to 96. And then I did the arithmetic here, and I got 140 over 96, and then I just reduced it from there. Okay, to get to 35 over 24. Now, textbook, they go about it by, and there's nothing wrong with it. Like I said, I just do things a little bit different. What they did was they got the least common denominator of 8 and 12. Right? It was 2 times 2 times 2 is 8, and 2 times 2 times 3 is 12. Well, we see that the largest of same thing, something we did in the previous section. Or was it the section before? I forget. I think it was the very first review. The highest power of 2 is 3, so 2 cubed is 8, and the highest power of 3 is 1, so 8 times 3 is 24. So the least common denominator here is 24. So what we did from there is we, or they rather, figured out, okay, so what do I need to multiply the 8 by? What do I need to multiply the 8 by to get to 24, and that's obviously 3. What do I need to multiply the 12 by to get to 24, and that's 2, and then of course all this stuff. Okay, if you prefer it this way, you can. If you prefer it my way, you can do that as well. Okay, but we're gonna do one more, probably, I'm sure. Yeah, there it is. Okay, so again, we're gonna do it the way that I am. Oh, this might get actually pretty ugly. Might get pretty ugly, but let's just do it anyways. Maybe to demonstrate how to do it, right? Because again, I'd probably do it this way anyways, right? So starting off, right? What is 7 times 36? Okay. Well, I mean, truthfully, I don't really know. So 7 times 36 is going to be 252. Oh, I can tell already this thing. This probably might not be good. But anyways, 252. And then plus was 7 times 45, less 315, all over 45 times 36, 1620. Okay, so I can tell this is not going to be a good idea. 252 plus 315 is 567 over 1620. Alrighty, so 567 is divisible by 3. Is 1620 divisible by 3? Yes, okay, so we can proceed, and we will here. Okay, so let's go ahead and proceed. So I can reduce 567 over 1620 because I know that they're both divisible by 3. I know this because I put them into my calculator. I said 567 divided by 3. Well, 567 divided by 3 is 189. And 1620 divided by 3 is 540. Okay. Well, we're going to do it again. Well, what is 189 divisible by 3? Oh, we're in luck. 189 is indeed divisible by 3. Okay, so realistically, I probably could just divide it by 9 to begin with, right? But anyways, I can divide those by 3. They both go in evenly, right? 189 divided by 3 is 63. And 540 divided by 3 is 180. And wouldn't you believe it, I'm pretty sure you can divide these by 3. I know 63 is divisible by 3, and I know 180 is divisible by 3, so I could have actually probably divided this whole thing by like 27 now. Okay, so 63 divided by 3, well, that's going to be, goes in 10, 20, 21, and 180 is 60. All right. let's see. I can do it by 3 again. Okay, so I can do it by 3 again. I know that 3 can go into 21 7 times, and I know that 3 goes into 60 20 times. Okay, so this is a very good teaching lesson because, again, I would just do it this way anyways, because it's, I guess that's how I learned it many, many years ago. At the end of the day, let's look at this. Let's look at the problem here. At the end of the day, notice how we're finding we have to do a prime factorization tree of both these numbers, 45 and 36. Once I find the prime factorization tree of both of these numbers, I have to figure out what the least common denominator of these would be. The least common denominator would be the least common multiple, right? What's the smallest number that both these numbers will go into? Well, it's 180. Okay, and so we have to multiply 45 times 4 in this step right here. 45 times 4 to get to 180. We have to multiply 36 times 5 to get to 180. And there's still quite a bit of computation involved here. See, notice there's a lot more computation involved. So realistically, I guess this problem just plain sucks anyways. So which way do you want to go about it? It's up to you. Okay, so now let's talk about subtracting fractions. Okay, so subtracting fractions is honestly the pretty much exact same way that we did the addition of fractions. All right, we're going to start just like we did the section. If we have a common denominator, and again I did the same thing. I guess it doesn't necessarily matter that I you know what? Let's go ahead and just snip the whole thing. Actually, we don't have to snip. That was the whole point. It's the same procedure that we did when we add fractions with like bases, right? Notice how we have 9 over 10 and 7 over 10. Well, 9 over 10 minus 7 over 10, you just say 9 minus 7, which is 2, and you get 2 over 10, and then of course you can reduce that down to 1/5. Okay, so it's just like how you do addition, except you have a subtraction sign in there. Okay, example 7 is also more of the same. Wait, no, it's not. Okay, I take it back. I'm sorry. So 9 over 7 is kind of the same as the addition, but we're going to jump to example 8 because example 8 is going to be the more difficult one, right? So example 7 is the easier one with the smaller numbers, but example 8 is a little bit more difficult one. But we're going to do it the same way we did addition. Same way, okay? So what I'm going to do is, if you recall, let's go ahead and write it down in case this procedure has been forgotten. Okay. So what I did, if you recall, I did 7 times 28. Well, 7 times 28 is going to be times 28, 196. So we have 196, and we're going to put a minus sign there. And 3 times 20 is 60. Okay, again, like this. 3 times 20. And then there's a minus sign in there. Okay, so this minus sign is right here. So recall, let's go back to previous examples. We had the addition sign, and put the addition sign there. Okay, so again, it's the same procedure, it's just instead of addition, we put subtraction. Okay, and then we have 20 times 28, which is going to be equal to 560. Right, and then we do 196 minus 60. It's going to be 136. Over 560. Okay, so we're in luck here because they're both divisible by 2. So, like I said, if you have the division of 2 available to you, then do it. Right. So we can reduce this. 136 divided by 2 is 68. That looks a little weird. 68. And then 560 divided by 2 is 280. Okay, and these two are divided by 2 as well, right? 68 is 34 over 140. And then that's 17. Golly, this pen. It happens. 17 over 70. And 17 over 70, I don't... Well, 17 is prime, so we got to stop there, right? So 17 over 70 should be my solution here. There it is, 17 over 70. So I think if I were to erase one of my colleagues and they did the least common denominator solution, I might beat them. I don't know. It's one or the other. Like I said, I was taught one way. This textbook is teaching another. And since you are in my class, you get to teach it, or you get to learn it my way. Okay? That concludes review section 3.